what is the name of this compound that has been formed by KMnO4 cold acidified? So under cold condition, when KMnO4 is added into any carbon-carbon double bond, I mean any alkene, then this diol is formed. OH group is introduced on the both doubly bonded carbon, and I mean the bond is broken, and OH group is added or that is introduced on the both doubly bonded carbon atoms. Now the next phase is what is its name? What is its systematic name? What is its IUPAC name, and so on. Good. It's a prop. Prop means three carbons. Carbons are single bond, so you will write in. But there are two functional group, double functional group. I mean, this is the one functional group, but that is twice in the molecule. So we will mark hyphen. The position is one. Good. Its position is two. So 1 comma 2 dash. Total they are in two. It's called diol. Propane 1,2-diol. Propane 1,2-diol. So propene 1,2-diol is the name of this compound. Now that's all about if you are keeping this cold KMnO4, then it will not go into the further oxidation. So that is the final compound. This is a final compound. Come towards the second one option. In second option, if I am going to add KMnO4, if I am going to add acid, or I can also add alkaline or alkali. I mean, one of the alkali or acid can be used, and I'm going to heat this time. So this is called hot condition, not the cold condition. So if I'm going to heat this time, then what will happen? It's a necessary, it's an important thing. It is one of the most oftenly asked question. Then what will happen if we are going to heat this alkene? Then what will happen? This CC, both bonds are broken down. When we add cold KMnO4, only one of the bond, that is a pi bond, one of the bond is pi bond, one of the bond is broken, and there is there is addition of OH group, and this is also said to be hydroxylation. This process is said to be oxidation or hydroxylation or oxidation. It's also said to be oxidation. Oxidation. Wait a minute. Now come toward this one. If I'm going to use KMnO4 acidified or alkaline KMnO4, I mean in the presence of acid or alkali, and I'm going to heat it as well. So this time there is the complete cleavage, complete breakage of this CC double bond. So molecule is going to change into two pieces. Molecule is going to break down from here where there is a double bond. From here, this molecule is cut into two parts if there is only one double bond. So now just have a look. What is the number of carbon atom on this right hand side? How many carbon atoms are there? Carbon, just count the carbons. First of all, one. If the one carbon is present on either side, on the right hand side or on the left hand side, then you will change this carbon into CO2, and its hydrogens will be changed into H2O. So if whenever only one carbon is left in any option, if there is only one carbon left, then this carbon will be changed into CO2 and H2O. So the next one thing is this one, basically, that if it is having more than one carbon atom, then this carbon will be having double bond O. So now I will introduce double bond and O. So what will be its shape? What will be its formula? This C double bond, one methyl group, this one, and one hydrogen. So it has become an aldehyde. But as you know, as we are heating in the presence of acidified KMnO4, so this aldehyde will change into acid, carboxylic acid. Now it will be at this one acid. So it has become an acid. So finally, if I'm going to heat this alkene with KMnO4, hot KMnO4, acidified and alkaline, so there is the formation of CO2, H2O, and acid, ethanoic acid basically. So generally, the carbon containing compounds are CO2 and ethanoic acid. So this is the basic way out, this is the basic theme to convert any carbon-carbon double bond compound into CO2, into acid, into, there might be possibility of the formation of ketone as well. So basically, carbon compounds can be changed into CO2 in this way, can be changed into acid, or it can be changed into ketone. So three carbon products are possible whenever you are going to heat any alkene with KMnO4. And sometime only CO2 is possible, sometime maybe only this acid is possible, sometime CO2 and both, as you have seen in this case, sometime CO2 and this acid, both formation is possible, and sometime just ketone is formed, sometime this ketone and acid is also formed. So any one of the compound, CO2, ethanoic acid, or any other acid, I mean, CO2, acid, or ketone, one of them or any two of them will be formed whenever you are going to oxidize carbon-carbon double bond. Listen it again. Whenever you are going to generally heat any alkene, it's going to make either CO2 or acid or ketone. Any one of them, any two of them, and so on. Now, I'm going to do another example. For example, I'm having this one compound. So, what will be formed, what is supposed to form when I'm going to add KMnO4 acidified plus heat, aqueous acid, KMnO4 and heat. What will be formed? What to do? Let me know, please. Okay, it's no issue. Our basic function is if we are using KMnO4, we are using H positive ion and we are heating this compound, then this carbon is broken down. This carbon-carbon double bond is broken down. Okay, now, is there any side is having only one carbon? No. So, it means that we will introduce C double bond O on this carbon, same is the case double bond O on this carbon. So, I'm going to write them once again. So, one of the compound is this one. What compound is this one? What is the name of this compound? What is the functional group of this compound? Yes, probe on. Probe into on, or just propanone. And this is the ketone, it cannot be further oxidized. Now come toward this carbon, this side. What is the answer of this side? What this side is going to appear over here, that is this one. It's an aldehyde. Aldehyde can be oxidized further and it will be changed into acid. What is the name of this compound? Ethane OIC acid. No, in case of acid, there is no need to write ethanoic acid. There is no need to write any number. Yes. So basically, this is the way how to diagnose, how to predict, and so on. Let's see. I'm going to write another example. For example, I'm having CH3, CH2, and CH3 double bond. This is having CH3 and CH3. So again, I'm going to add KMnO4, that is acidified, H positive ion aqueous, and I'm going to heat as well. So what is supposed to form over here? Just try yourself to I mean, find the answer of this one. Basically, you will have to apply the rules once again. I mean, what I told you, what to do, what are the basic steps to oxidize it. As you know, whenever there is the name of KMNO4, there is only one function of this KMNO4. It's an oxidizing agent. Then now, what to do? You are going to heat. Acidic medium is over here. What will be the step number one? Good boy. This double bond will be cut into two parts. Step number two. Yes. No, just, I mean, follow the step. Don't try to search out what it's going to be. Simply what I told you, what to do next. Oxygen. As you have seen, there is no single bond lying on each side or on any side. So simply, we are attaching, we are introducing this C double bond O. Same is the case over here, C double bond O. So we have made these compound. So what are these compounds? I mean, what is the compound over here? One compound is this one, and other compound is this one. So, good boy. But 2-on. On. It's a ketone. It's a but in 2-on. What is this one? Good boy. 3 carbon can be simply written as propane on. Okay. Can you further oxidize butane 2-on or propane 2-on? Answer is no. No. Because they are ketones and these cannot be further oxidized. Now, come toward the next one. Another example I mean. So first of all, I mean, one thing more, that you will have to once again revise some major rule. Alcohols can be oxidized, primary alcohol can be oxidized into aldehyde, and then aldehyde can be oxidized into acid. So finally, a primary alcohol can be changed into acid. Secondary alcohol, it can be changed, it can be oxidized into just ketone. Secondary, all type of secondary alcohol can be changed into ketone, and ketone cannot be further oxidized. The third one is this one. If we are having alkene, then we can oxidize alkene by two way. If we are using the cold condition, there is only one product. There is introduction of two OH group on the doubly bonded carbon atom, and one of the double bond is broken. OH are introduced on those carbon. I mean, doubly bonded carbon will get OH group, and there is a breakage of one carbon bond. So in case we are going to heat with KMNO4, this is called hot condition, then both of the double bonds, I mean, basically double bond is made up of two bonds. One is sigma bond, one is a pi bond. If you're going to heat, then initially, at first step, both bonds are broken down, and molecule is changing into two parts from that position, from that double bond. So what will happen if you are having only one carbon atom? Then this carbon will change into CO2, and these hydrogen will change into H2O. If any side that is having more than one carbon atom, it will be, I mean, it may be changed into acid or ketone. You are having only two options. If there are two carbon atoms left, or more than two carbon atoms are lying on each side, on every side, I mean, you can change this one into either can change it into acid, carboxylic acid, or the second option, it will be changed into ketone. There is no any third option. But if the carbon is equal to 1, it always be changed into CO2. So that is the basic major points outline that you have to remember. Now let's see over here. Once again, I'm going to add another example. For example, CH2 double bond CH2. I'm going to add again KMnO4, H positive ion, aqueous, hot. What is the product outcomes of this reaction? What is the first step, Taha? Please recall this first step. Cutting the double bond. Exactly. What is the second step? Just, memorize the steps for each topics in chemistry, especially in organic chemistry. It will be very easier to you. Just memorize the step and just apply those steps whenever you are going to solve the question. Yes. Good. Then, yes. Yes. So, 2 mole of CO2, though 2 carbons are over here, and obviously 2 mole of H2O will form. So that is the, every time if the either side or the both side are having just 1 carbon. Now come towards another one question. Let's suppose CH3 and CH double bond, CH and CH3. And again, sorry, if I'm going to add KMnO4 plus acid plus heat, what will be formed? Correct. Correct. What should be over here? I wrote CH3, C double bond O, then what next? OH, correct. I mean, aldehyde will not be formed. Either the acid will form or ketone will form. So acid, what about the next portion? Here, OH, yes. So how many types of compounds have been formed in this reaction? What is their name? Good. Acetanoic acid. This is correct. Now the next thing is, only one type of compound has been formed. So whenever they are asking how many type of products are made or formed, then you will write only one type of compound has been formed. So because they both are same, we can write the 2 mole of like that, as we wrote over here, 2 mole of CO2. So we can write, 2 mole of ethanoic acid over here. So that's, I think, about this one. That's enough. Now I'm going to add cold this time. Cold KMnO4 plus OH negative ion, let's suppose. So what will be formed over here if I'm supposed to add cold KMnO4 into this compound? And again, I'm going to delete this double bond. Oh, these are not the original one. So what should be formed over here? No, basically we cut only one carbon-carbon bond, not the both bonds. Then, then the next step is basically we will add OH group. So I'm going to write it over here. CH3 CH. This time I'm writing single bond rather than double bond. H CH3. So what is the new compound or bond over here? Here, that is OH. Okay. Good. OH. And boom. So on. So this time diol is formed and so on. Now the last question about this topic especially and for today class as well, that let's suppose an alkene let's suppose X was oxidized to make ethanoic acid and propanone. We oxidize an alkene and there was the two products. So can you find the formula of X alkene? What was that X alkene? This time we will have to move in a reverse way. An alkene was oxidized, by the help of hot KMnO4, and these two compounds were formed. So he is asking this time, can you find the formula of that alkene and how to formula of that alkene? Let's see over here. It's simple. It's quite simple. Basically, just locate these two carbons, and कौन से carbon, which one carbon? C double bond O, C double bond O. Then, is there any OH group on the C double bond O? Is there any OH group? No OH group. Then I am going to locate this one. So the first step is, you can say, I'm going in a reverse way. The step number 1, change OH group into simple H. Change OH group into simple H. So I'm going to remove this oxygen. Now, the next step is remove CO or join C double bond O. Join C double bond O. So I'm going to remove these oxygen and I'm joining these two carbons. Right? I'm joining these two carbon by a double bond. You will remove these oxygen as well, and then after that you will remove this carbon. You will join this carbon and this carbon. Doubly bonded carbon, C double bond O carbon will move to make double bond. So what is the answer? The answer will be CH3, this one C, here this is only H, here this is a double bond. This is the new double bond formed What about this one? This carbon, its one side is having CH3, other side is also having CH3. So that is the formula of alkene X. So this is the formula of alkene X. What is its name? I'm going to write it again over here. CH3, CH, double bond, CH3, CH3. What is its name, first of all? This is the final answer of this X alkene. If it is oxidized, it will make acid and ketone. So what is its name? Please let me know. Two, first two. 2 dash, the branch, yes, methyl. In case of branch, you will write YL with it. 2 methyl, how many carbons are in the longest chain? 4. It's a bute. And one carbon is carbon-carbon double bond. So we will write as position. What is the position of double bond? Good, second. Because it's lying between 2 and 3 number, the small number will be the position of double bond. Butene, ene for double bond. So that is the name of this compound, and that's all about this oxidation.